Assalamu alaikum warahmatullah. So in the last lecture we talked about the how to find the inverse of a matrix. Okay. Now we will see how to solve the set of linear equation. That means solution to set of linear equation. That's what we are going to see. So how to find the solution of set of linear equation by using the computerized methods. So the first method that we are going to discuss is the matrix inversion method. Okay, matrix inversion method. Now consider an example. You have a set of linear equation which is given as x1 minus x2 plus x3. 3x3 is equal to 5. Okay, another equation 4x1 plus 2x2 minus 2x2 minus x3 is equal to 0. Then x1 plus 3 x2 plus x3 is equal to 5. Okay, so this is the equation. So we want to find x1, x2 and x3. How to obtain x1, x2 and x3? So we will be solving this equation by using the matrix inversion method. Okay, so let me check this. 1 minus 1 and 3, 4, 2 and minus 1, 1, 3 and 1. Okay, so I can write this equation in matrix form as ax is equal to b, a into x is equal to b form. That means I can write this equation as 1 minus 1, 3, 4, 2 minus 1, then 1, 3, 3. Okay, okay, so not 3, it's 1. 1, 3, 1. Okay, it's x3, so it's the coefficient is 1. Here the coefficient is 1. Sorry. Now, so 1, 3, 1. Now, my x matrix, I can write x1, x2, x3. I want to find this x1, x2, x3. And this is b1, b2, b3. That means it is 5, 0, 5, 0, 5. This is my B matrix. Okay, this is my B matrix, this is my X matrix, and this is my A matrix. But you know that now we got X is equal to B, and you know that how to find the inverse of a matrix. Inverse of a matrix is nothing but the adjoint of the matrix divided by the determinant of the matrix. And also you know that if you multiply any matrix with A inverse, you will get it as I, and if you multiply like this, post multiplication, A inverse also will give you I. And what is I? For example, I2 is a matrix of diagonal elements as 1, and I3, this is example for I3 is a 3 by 3 matrix. Okay, this with diagonal elements as 1. Now we want to find our solution. So I can find my solution as, you know that this is my equation, Ax is equal to b. I will multiply both sides with A inverse. So I am multiplying both sides with A inverse, but you know that this guy is I. A into A inverse is I, and this is X. Now we get A inverse into B. So I into X is nothing but A inverse into B. So you can find the solution by using the matrix inversion method. Matrix inversion method as A inverse into B. So first of all, you have to find A inverse for your problem. So you want to find the A inverse, but it is given that the matrix A is, we know this matrix A, this is our matrix A. I will rewrite it again. So the matrix A is 1 minus 1 and 3, then 4, 2 minus 1, 1, 3, 1. Okay, so this is our matrix. Okay, now we are going to find the cofactor of this matrix. So for example, first of all, we will be finding the minor matrix. Minor, okay, what is the minor? We will be making the minor matrix as shown here. You see, the first I will be taking this element, so this will form the minor. So the determinant of 2, -1, 3 and 1, that is the minor for that. Now I will take the another part, this element. What is the minor? You have this and you have this, okay. So the determinant of 4, 1, -1 and 1, okay. Now you have the third element, this one. So you will remove this particular row and column. So what is there? You can consider this. So this is 4, 2, 1 and 3, okay. Now, so this is the minor of A anyway. Now you will take this guy, the element 4, for example, you will take the element 4. So you will remove this row and column. So what is remaining? It is -1, 3, okay. Then -1, 3 and 3 and 1, okay. Next you will be considering the element 2. So you will be removing that row and column. So it will be 1, 3, 1 and 1. And next you will be considering this guy, okay. So you will remove that row and column. So it will be 1, -1, 1 and 3, okay. And next it's not so easy procedure. Next you will be considering this 1. So you will remove that row and column. So what is remaining here? It is -1, 3, okay, -1, 3, 2 and -1. Now you will take this guy, okay. So you will remove that row and column. If you remove the row and column corresponding to that, you will get 1, 3, 4, -1, and you will consider the last as this one. So you will remove that row and column. You will get 1, -1, 4 and 2. This is the minor matrix, okay. So we will calculate this. So minor of A, we will finally find the elements. So you see here, this is 2 into 1. So 2 into 1 minus 2 into 1 minus -3. That means it is 5, okay. Now this is 4 into 1 minus -1, again 5. Then it is 4 into 3, it's 12. 12 minus 2 is 10, okay. Now this is -1 into 1 is -1 minus 3, it is minus 10, right? It is minus 10. Now 1 into 1 minus 3, 1 minus 3 is -2, okay, -2. Now 1 into 3 is 3, 3 minus -1 is 4. Now you see here, this is -1 into -1 is 1, 1 minus 3 into 2 is 6, 1 minus 6 is -5. Next 1 into -1 is -1 minus 12, it is -1 minus 12, okay, it is -13. Then 1 into 2, 2 minus -4 is 6, okay. So this is the minor of A. Now how to find the cofactor? To find the cofactor, you have to assign the sign. So what is that sign? It is plus, minus, plus, then minus, plus, plus, sorry, not plus, minus, then plus, minus, plus, okay. So we are going to find the cofactor of A. Now the cofactor of A, which is nothing but C, we will write it as a matrix, I will first write my 5, 5, 10. Okay, there is no space here. I will, okay, the cofactor of A is equal to C. So I am going to write my C as cofactor. So I am going to write here, I will first write all the elements 5, 5, 10, minus 10, minus 2, 4, then minus 5, minus 13 and 6. Okay. After that I will assign the sign. You see here the first element, it is positive, there is no change, so there is no change in the sign, but this element should be multiplied with minus 1, so it is minus. This element, there is no change, you see. Now what about this? You should multiply with minus 1, so this become plus 10. Okay, it's become plus 10. Then there is no change, and here you have, there is a change. Here there is no change, there is a change at the third position, you see. So you have to multiply with minus 1. So next there is no change. Okay, there is no change, but here there is change. So you are going to multiply the minus 13 with minus 1, so it become plus 13. Next you have no change. So this is the cofactor. So you got the cofactor. Okay. Now you know that adjoint of the matrix A, adjoint is of A is nothing but, you have to take the transpose of the cofactor, which is nothing but, you can take the transpose, so you will get it as 5 minus 5 and 10. Okay, then 10 minus 2 and minus 4, then minus 5 minus 13 and 6. Okay, that's it. This is the cofactor. Now we want to find the determinant of A, because we didn't find the determinant of A. So this is the cofactor of A. We got the cofactor, and what was our A? We have the determinant of A is nothing but the determinant of, this was our A, it is 1 minus 1 3. So 1 minus 1 3, then 4 2 minus 1, then 1 3 and 1. Okay, 1 3 and 1. Okay, this is, so I will find the determinant of A. So first of all, I will take, for finding the determinant, I will take this element, so it is 1 multiplied with, I will find the determinant of the remaining part. That's it. This is 2 minus 3 1. Okay, so the sign convention will be plus, minus and plus for finding the determinant. Okay, so this is plus 1, I am assuming. Okay, now this is finished. Now we have this minus sign, so minus, you see this is minus 1. Okay, I will use different color. So this is minus 1, so minus 1 into the determinant of, what is that? I will remove that row and column, so what is remaining here and this one. Okay, so it is 4 1 minus 1 and 1. Okay, next is the third part, so it's plus. Okay, so previous one I will use this minus and this is minus. Okay, now plus, next 3, this is our 3. So what is remaining? This is our row and column. So this is 4 2 1 3. Okay, so this will become 1 into 2 into 1 is 2 into 1 is 2, 2 minus minus 3 is 5, minus, you see here there is minus here and here, so it becomes plus. So 1 into 4 into 1 minus minus 1, it's 5. Okay, plus 3 into 4 into 3 is 12. 12 minus 2, it's 10. Okay, so you will get 5 plus 5 plus 30, which is equal to 40. Okay, so got the answer. So you got it, the determinant. So you can find now A inverse as the adjoint of A by determinant of A, which is equal to 1 by 40, because determinant is 40, and adjoint, you know the adjoint is the cofactor transpose, you have already found it. 5, 10, minus 5, then minus 5, minus 2, 13, then 10, minus 4 and 6. Okay, that's it. Now you can find the solution. X is equal to A inverse into B, which is equal to, I got the A inverse, I will substitute here. So 1 by 40 and 5, 10, minus 5, minus 5, minus 2, 13, 10, minus 4 and 6. And I will multiply it with the B, and B matrix, you know what is that B matrix? Yes, this is my B matrix, 5, 0, 5. So 5, 0, 5. So you multiply this, you will get the answer as 0, 1 and 2. This is your answer. So what is this? This is nothing but your x1, x2 and x3. So that means that your x1 is 0, x2 is 1 and x3 is 2. So the answer x1 is equal to 0, x2 equal to 1 and x3 is equal to 2. So this is your answer. Okay. So this is how to solve this kind of problem by using matrix inversion method. So you have to practice more problems. Okay. So there are other methods also for solving. Okay. There are other methods for solving. So I will give you an homework. You can practice it in your home. You have the matrix A. You have a system of linear equation. Solve linear equation. Solve x1, 2x1 plus 2x2 plus 0 x3. That means there is no x3. Okay, that's equal to 6 and minus 2x1 plus x2 plus x3 is equal to 3 and 3x1 plus 0x2. That means there is no x2. That's the meaning. Okay, that means 0x2 plus x3 is equal to 6. So let me check. 2, 2, 0, then minus 2, 1, 1, 3, 0, 1. Okay, so you have to solve this. Okay, find the answer by using matrix inversion. Okay, and the answer for this is x1, x2, x3. x1 you will get 1, this is 2, this is 3. So you will get this answer. Check whether you are getting this answer. So how to solve this? Find A inverse, and this is the first step. Then find A inverse into B, that will give you x. Okay, which is equal to x1, x2 and x3. So solve. This is an homework for you. You can do it. Okay, this is a practice problem, we can say. That's practice problem. You can practice from your home. Okay, now we have one more method. We have one more method which is another method which is known as the Cramer's rule. Cramer's rule for solving the linear equation. For solving linear equation. So we have the same equation. Let us assume that we have an equation Ax is equal to b. So in the previous case I will write the same thing. Okay, I will write the same equation. You see here 1 minus 1 and 3, then 4, 2, minus 1, then 1, 3, 1. Okay, into x1, x2, x3 is equal to 5, 0, 5. This is the Cramer's rule. this is the equation. Now we are solving by using the Cramer's rule. Okay, so this is the Cramer's rule. We are going to solve this equation by using the Cramer's rule. Now, first of all, we will be finding, for solving the by using Cramer's rule, we need two things. So how to find? First of all, we will be obtain the matrix here. This is a 3 by 3 matrix, so we will be obtaining, we have three values, three variables here, so we will be obtaining the matrix AIs. What is AI? AI means actually A1, A2 and A3. Okay, now we will be also, so we will be finding the AIs. After that, we will find the determinant of AI. That means determinant of A1, determinant of A2 and determinant of A3. And also we will find the determinant of A. After that, we will find x1 by determinant of A1. Okay, determinant of A1 divided by the determinant of A. So that's how we are going to solve this. Okay, by determinant of A. Okay, determinant of A1 divided by the determinant of A. So this is nothing but our x1. And how to find x2? Determinant of A2 divided by determinant of A. And how to find x3? Determinant of A3 divided by determinant of A. So in general, you can find xi as determinant of AI divided by determinant of A. So this is the general rule. Okay, general rule in general. Okay, general rule. So this is what we are going to find out. So what is our A? I will write the A here first. Okay, our A is 1 minus 1, 3. We are solving the same previous problem by using another method. So 1, 3, 1. Okay, this is my A. And what is my A1 and what is my B here? I will write my B also. B was 5, 0 and 5. Okay, so what is my A1? A1 is actually used to find x1, and you know that x1 is coming in the first position. So in the first position, I will write, instead of x1, I will write my 5, 0, 5. Okay, you see here I am writing here 5, 0, 5. I am writing my B here, the first position, and remaining things will be same. Remaining will be same. Okay, so this will be 5, 0 and 5. Okay, 5, 0, 5. Okay, anyway, this is 5, 0, 5. The next elements will be same. Minus 1, 2, 3, and this is 3, minus 1 and 1. Okay, is it clear? Yes. Now what is A2? For finding A2, you can see that this row, this column I will replace with 5, 0 and 5, and the remaining will be same. 1, 4, 1, and this is 3, minus 1 and 1. Okay, next we will see what is A3. Okay, for finding A3, we will see, I will use a different color. Okay, that's it. Now you see here, this column I am going to replace with 5, 0, 5. Okay, and the remaining will be same. 1, 1, minus 1, 4, 2, 1, 3. Okay, so the remaining things all are same. Okay, only I will be changing those columns. Okay, now after that I will find the determinant of A1, and determinant of A1 means determinant of 5, minus 1, 3, 0, 2, minus 1, 5, 3, 1, and you know how to find the determinant. Actually you will be getting this answer as 0. You can check it. Okay, How to find the determinant? You first take this element 5 and then consider the remaining, then minus 1 into the remaining here, okay, like this. So the same method that I have used in the previous problem. Okay, next A2 I will be calculating as the determinant of 141,505, 3 minus 1 1. So you will get this answer as 40. You can check it. And you know that now determinant of A3, you will get it as A3, the determinant of 1 minus 1, 5, 4, 2, 0, 1, 3, 5. You will get this answer as 80, I think so. Yes, you can calculate and verify this. Okay, we have already discussed how to find the determinant. Now, what is determinant of A? Determinant of A is determinant of 1 minus 1 3, that we have already seen this. We have already calculated 1 3 1, which is equal to 40. Okay, now you got these answers. Now you can find x1, x2 and x3. This is nothing but the determinant of a1 divided by determinant of a, which is equal to 0 divided by 40, which is equal to 0. You got the answer. Now this is nothing but determinant of a2 divided by determinant of a, which is equal to 40 divided by 40, which is equal to 1. And this is determinant of a3 divided by determinant of a, which is equal to 80 divided by 40, which is equal to 2. So you got all the answer. So this method is known as the Cramer's rule for solving the linear equation. Okay, I hope this is clear to you. So this is the Cramer's rule. Okay, so you can solve the linear equation by using the Cramer's rule also. Okay, so we will continue our discussion on solving the set of linear equation. So next we will see another method for solving the set of linear equation is by using the Gaussian elimination method. So it's Gauss elimination method. Okay, so all this can be programmed in the computer. It's very easy to program all these things in the computer. Okay, so first of all, let us consider a set of linear equation a11 into x1 plus a12 into x2 plus a13 into x3 is equal to b1. Now a21 into x1 plus a22 into x2 plus a23 into x3 is equal to b2. Now a31 into x1 plus a32 into x2 plus a33 into x3 is equal to b3. I can write it in the matrix form. I told you a11, a12, a13, a21, a22, a23, a31, a32, a33. And you know that this is x1, x2 and x3, and on the right hand side b1, b2 and b3. And all of you know that we will be solving a set of equation. For example, you have two equation, x plus y equal to 3, x minus y equal to 5. Okay, x minus y equal to 5. How to solve this? You will just add this equation. Now 2x is equal to 8, and you can find x is equal to 8 by 2, which is equal to 4. This is the one method to solve this equation. So what you are doing by adding this, by adding two equation, you are making the coefficient of y as 0. So you are removing y from here. Okay, so I am going to remove this anyway. So you are removing y, but here you see here there are three variables. So if you want to find x, you have to remove y and z. If you want to find y, you have to remove x and y. If you want to find z, you have to remove x and y. If you want to find z, you have to remove x and y. So what I am going to do is that here we will be in Gaussian elimination method, we will be reducing this matrix A. We will be first finding an augmented matrix. So we will first define the augmented matrix as your A11, A12, A13. Then I will augment my B1 also. Next, A21, A22, A23. Next, I will augment my B2. Now, A31, A32, and A33, I will augment B3. So this matrix is known as the augmented matrix. Okay, augmented matrix. Okay, augmented matrix. So before that, we have some conditions. We will make this guy A11 is greater than A21 and A33. Okay, so we be writing the equations. So we will write the equations in the order such that A11 will be greater than A21 and A21, and also A11 will be greater than A31. So like this. Similarly, we will try to arrange the equations. A22 is greater than A21. Sorry, not A21. A22. We are talking about now this element. A22 should be greater than other these and this A12 and A32. A12 and A32. Similarly, we will talk about this guy. A33 should be greater than. So this is finished, and okay, I have used the same color. Next, A33 should be greater than A31 and A32. Okay, so this is what. So these three conditions. So we will be writing the equation in a order such that these conditions are satisfied. The above conditions are satisfied. Okay, and this process is known as pivoting. Okay, pivoting. What's the name? This process is known as pivoting. So we will take an example anyway. So we will see an example now. Okay, we will see an example. So before that, okay, I will write one more thing. And also our matrix, our augmented matrix. So we will reduce our augmented matrix. Suppose this is our augmented matrix, A12, A13, and this is B1, A21, A22, A23, and A31, A32, and A33. This is B2 and B3. So we will transform using row operations to something like this. This is our augmented matrix. Let's say B1, B2, and B3. This is something different. B1 tilde, B2 tilde. But you see, this is 0, this is 1, and this is 1. This is 0, this is 0. Okay, and this is 0, and this is 0. And maybe some elements are here. Okay, maybe here also some elements are here. Something like I will not denote it as something. A12 tilde and A23 tilde. Okay, and A13 tilde, and this is A23 tilde. So you will be transforming this matrix into this particular form. Okay, now this is showing the coefficient of Z. This is showing the coefficient of X. This is showing, okay, not Z, X1. So this is showing the coefficient of x3, and this is showing the coefficient of x2, and this is showing the coefficient of x1. You see here that the coefficient of x1, if you take the last row, the coefficient of x1 is equal to 0, x2 is equal to 0. That means there is no x1 and there is no x2. And the coefficient of x3 is equal to 1. That means that you have only x3, and your x3 is, you will get directly x3, okay, as B3. So that will be your answer. So we will see a problem, then it will be easily you can get it, okay. So example, solve the equations. I will write the equation x plus okay, solve x plus 5y plus 3z. You see here I am using the variables x, y and z. There is no issue, anything x1, x2 or x3 you can use, okay. So this is your first equation, and the second equation is 2x plus 4y minus 6z is equal to 10. Sorry, not 10, it's equal to minus 4. So this is the equation number 2. Next is x plus 3y plus 2z is equal to 5. So first of all, you see here I will use the pivoting, okay, before proceeding. So this is equation 3. But when I check this equation, you see here I will consider the x variable. So the coefficients you have from the first equation, second equation and the third equation, the coefficients of x, here it is 1 from the first equation, and here it is 2, and here it is 1. So which one is biggest? So the biggest coefficient is this one. So I will write this as the first row of the augmented matrix. So I will write the augmented matrix now. Augmented matrix, the first row should be this element. So 2, 4, minus 6, okay, and this is minus 4, okay. Next I will talk about y. For y, you see the coefficients are 5, 4 and 3, okay. 5, 4 and 3, this is from equation 1, this is from equation 2 and this is from equation 3. So which is big one? Yes, this equation is having very large y coefficient. So I will write next this one, okay. So this is 1, this is 1, this is 5 and this is 3 and this is 10. Now remaining one equation is there, I will write it, okay. Okay, so next I will be writing the remaining equation 1, 3, 2 and 5. So this is my augmented matrix. So I hope this is clear to you, okay. So if you compare this, you can see this is the biggest number in this first column, and this is the biggest number in the second column. You see the second row, okay, second column, and this is not a biggest number because we have considered x and y. So the remaining equation we are writing, okay. Now we will be converting this augmented matrix into this particular form. That's what I am going to say. So we are going to convert the augmented matrix. So I will write the augmented matrix once again, okay, once again. So I will write the augmented matrix. Augmented matrix, I will give some name to the augmented matrix as AM, okay, augmented matrix, or okay, augmented matrix. So my augmented matrix is given as, let's say it's 2, 4 minus 6, 2, 4 minus 6 and 1, 5, 3, 1, 5, 3, then 1, 3, 2, 1, 3, 2, and this is minus 4, 10, 5, minus 4, 10 and 5. Now you can consider this is row 1 this is row 2, this is row 3. So we will perform row operations. That means you can add or subtract between row. You can add or subtract between rows. Okay, to obtain upper triangular matrix. What is this upper triangular matrix? So upper triangular matrix is the matrix of this kind of form. That's what I am saying, this kind of form. This is an upper triangular matrix, because it contains upper entries only. Okay, upper and with diagonal elements 0. Okay, with diagonal entries 1, diagonal not 0, it's 1, with diagonal entries as 1. Okay, so we will see how to solve this. Okay, so first of all, I am going to perform the row operation on this, and I will get an matrix, new matrix. Okay, I am going to perform the row operation. I am going to multiply my row 2. Okay, I am going to change my row 2 as minus 2 times row 2. I am multiplying minus 2 with my row 2. So I am not going to change anything from row 1. So it is 2, 4, minus 6 and minus 4. But for row 2, you see here, this is row 2. I am multiplying this with minus 2. So if I multiply with minus 2, I will get it as minus 2, then minus 10, then minus 6, and this become minus 20. Okay, next I will also transform my row 3 as row 3. This is row 2 and this is row 3. I am going to change it as minus 2 times row 3. I am going to change. Okay, now you see here I am going to change it. So it has become minus 2, minus 6, minus 4, okay, minus 4 and minus 10. Okay, so you see here, you have got something like this. Okay, after this operations. Okay, I will now what you can do, I told you we want the matrix like this, so that we want the entries here as 0, we want the entries here as 0 and this entry is as 0. So first of all, we will be focusing on the second element and make it 0. Okay, we will focus on the second element and we will make it 0. So we want to make this guy, so now we are focusing here, we want to make this, okay, make this guy, okay, all to 0, make to 0. Okay, so what we will do with this, how we can make this to 0, that's what we are going to discuss. Now I am going to discuss here. You see, this is my row 1, there is no change. Okay, there is no change for row 1. This is my row 1. Okay, I will keep my row 1 as such. What is my row 1? There is no change. It's 2, 4, minus 6 and minus 4. So this is 2, 4, minus 6 and minus 4. Now I am going to change my row 2. I am going to do some operations on row 2. I am going to change this guy. Okay, I am going to check this. So row 2, you see here there is minus 2 here. I will add with row 1. Then what will happen? So row 2 I am going to change like row 1 plus row 2. So what will happen if you add these two? So 2 plus minus 2, you see what is this? You see what is row 1? I will just write row 1 as 2, 4, minus 6 and minus 4. Okay, and what is my row 2? Row 2 is minus 2, minus 10, minus 6, minus 2, minus 10 and minus 6, then minus 20. So if I add this row 1 plus row 2, and I am going to replace my row 2 with row 1 plus row 2, so what will happen? This becomes 0, and this become minus 6, and this become minus 12, and this is how much? Row 2 is minus 20, right? Yes, minus 20. So it become minus 24. You see here, this is my new row 2. So row 2 I am going to replace with 0, minus 6, minus 12, and minus 24. Now I got it. Now my row 1 is not changed at all, not changed. Okay. Now you can see I have rewritten the row 3 again. Okay. Now we have this matrix. So what we are going to do is that now we will be again changing this into another form. That means this is 2, this is 4, this is minus 6, minus 4, 0, minus 6, minus 12, and minus 24. And we will be changing our row 3 as row 1 plus row 3. Okay, so this will be 2 plus minus 2 will be 0, 4 plus minus 6 will be minus 2, and minus 6 plus minus is minus 10, and minus 4 plus minus 10 is minus 14. Okay, so you got this. Okay, now you see here I want to cancel some elements. That means I want to make this guy 0. I told you this before. So you see we want here 0. Here we want 0. This area, this position we want 0. So I will rewrite this again. I will rewrite my matrix in the next page anyway. So this is equal to 2, 4, minus 6, 2, 4, minus 6, 0, minus 6, minus 12, 0, minus 6, minus 12. Next, this is minus 4, minus 24, right? Minus 24. Now, I will multiply my row 3. I will take this guy, row 3. I will multiply row 3 with 3. Okay. So, I am going to change my row 3 with 3 times row 3. I can multiply this with row 3. So, if I multiply this, it become 3 into 0 become 0. 3 into minus 2 become minus 6. Okay. 3 into minus 2 become minus 6, and 3 into this is become minus 30. Okay, and this become minus 42. Okay, minus 42. But if I multiply with minus 3, what it will become? It will become, this become 0, this become plus, and this become plus, and this become plus. So now I am going to multiply with minus 3. Okay, for my convenience. Now you see here I will be writing this is 2, this is 4, this is minus 6 and minus 4, this is 0, minus 6, minus 12 and minus 24. Now my row 3 I am going to write as row 3 plus row 2. Okay, I will add with row 2. This is my row 2. Okay, this is my row 1. So I will add with row 2. So 0 plus 0 become, you see, 0 plus 0 becomes 0, and minus 6 plus 6 becomes 0, and this become 18, right? 18. And if you add these two, 42 minus 24, 42 minus 24 would also become 18. Okay, 18. So this become 18. So I told you this is the coefficient for the x, and this is the coefficient for the y, and this is the coefficient for the z, and this is your last v3 tilde. So you see here this equation you can write as 0x plus 0y plus 18z is equal to 18. There is no coefficient related to y, x and y. This implies that 18z is equal to 18. So z equal to Okay, z equal to 18 by 18, which is equal to 1, right? So z equal to 1. So you will be getting the value of z as 1. Okay, so we got z equal to 1. Now it's very easy. You take the second part, this equation. So it is 0x plus minus 6y or minus 6y, then minus 12z equal to minus 24, right? Minus 24. But you know the value of z. So this is not there in the picture. So 6y minus 12z, 12 into 1 is equal to minus 24. So minus 6y is equal to minus 24 plus 12, which is equal to minus 12, right? So y is equal to minus 12 divided by minus 6, which is equal to 2, right? So you got the answer for z and y. Now you can find the x very easily. Take this equation. Take this equation. So it's nothing but this is to find y. Now to find z, we are going to take the first equation, that is 2x. Okay, next 4y plus 4y. Now minus 6z is equal to minus 4, right? Minus 4. And x is equal to minus 4y plus 6z, right? Divided by 2. So you will get it minus 4 minus, what is 4 into y? It is 4 into 2, it's minus 8. Minus 4 into 2 is minus 8 plus z equal to 1. So plus 6 divided by 2. So it is nothing but minus 3. You will get the answer as minus 3. So you got the value of x, y and z. Okay, so this is your to find, not find as x. Okay, so x is equal to, so the answers are x is equal to minus 3, y equal to 2, okay, and z equal to 1. So this is the method. This method can be easily programmed in the computer. Inshallah, I will show you. I hope it is clear to you. Thank you.